and welcome back to another video. In this video, we'll be starting our discussion on linear regression. And the first topic in linear regression is scatterplots. So essentially what scatterplots are. So just like histogram, pie chart, box plots, all of these mathematical plots have certain functions. There is something that they represent. Similarly, scatterplots represents relationship between two quantitative variables. That is the basic functionality of a scatterplot. It represents how two continuous quantitative factors are related to each other. Now, the two quantitative factors, out of the two quantitative factors, one of them is an explanatory variable and the other is a response variable. Now, what is an explanatory variable and what is a response variable? Explanatory variable is the independent variable, and the response variable is something that is dependent on the explanatory variable. Just like in mathematics, the mathematics that we have studied, and when we had studied functions in mathematics, we used to write an extremely pertinent equation called y is equal to f of x, right? This was the most basic equation that we studied in mathematics when we studied functions. Here, if you look at y is a function of x. So x in this case exists independently. And x determines y. The way x changes, it has an impact on y. Henceforth, x in this case is explanatory and y in this case is a response variable. So let me reiterate. The variable that exists independently is called the explanatory variable because it explains the nature of the other variable. And the variable that is dependent on the explanatory variable is called the response variable. So the goal of scatterplots, or the basic functionality of scatterplots, is to show how the two continuous variables are related. Are they even related? And if they are related, how they are related? That's what scatterplot shows us. So the scatterplot shows us does the explanatory variable has an impact on the response variable, and how the scatterplots are plotted in RStudio. Scatterplots are plotted in RStudio using a function called plot. So we have already seen in our previous sessions how to plot a histogram, how to plot a bar plot, how to plot a box plot. Now we will see how to plot a scatter plot. These are the attributes that the plot function takes when we have to plot a scatter plot. We'll come to each of these in a little more detail. I'll open my RStudio. This is an example of a sample box plot that I have. I set for the site. So this is a this is a scatter plot. I'm so sorry. This is a scatter plot that is plotted between hours of study and score. Also, it is very important to note that when we are plotting a scatter plot, the explanatory variable is always taken on the x-axis and the response variable is taken on the y-axis. And this is how we plot our scatter plot. This is a basic example of a scatter plot. And so you can see in this example, I'll just zoom into my screen. And zoom this up. Yeah, now you guys can have a better idea. So this is how a basic scatter plot looks like. It has one variable on the y-axis and another variable on the x-axis. So here basically what we are trying to we are trying to show the correlation between hours of study and the final score in the exam. Now, each of these points, they just represent values in the XY space. So this, for example, this point right here represents two around 2.5 hours of study, and this his score was somewhere between 50 and 60. So basically each point shows the hours of study and the score of a student who gave this particular exam, right? So when we are plotting the scatter plot, by the way, this is the data that we have. I'm showing the first two rows. We have the name of the student, hours of study, and score. So when you plot the scatter plot using the plot function, you give few parameters and attributes as I've shown. Now, what are those attributes? First, you need to give your explanatory variable. Then you have to give your response variable. This main attribute is basically the heading of the scatter plot. What does the scatter plot represent? X lab is going to be the x-axis description. Y lab will be the y-axis description. X limit is basically the minimum and the maximum scale of the x-axis. Y limit is the minimum and the maximum scale of the y-axis. ECH basically determines how these points are going to appear. What is going to be the shape of the points? If I just change this ECH to 5, you can see the difference. It has taken a diamond shape. So how do you want to represent your scatter plot? What should the shape of the points? That is determined by the PCH attribute. The next attribute is the color attribute, which decides what will be the color of the points. So I can change it accordingly. And finally, we have the CX lab attribute that basically helps us to modify the size of the X lab and the Y lab. So these are some of the common attributes that you will encounter when you are plotting scatter plots in R. Now going back to our discussion, so when you come across a problem, it will always be a question for you all to actually surmise in the given scenario which variable is my explanatory variable, which variable is my response variable, and if there is a temporal relationship between the two variables. Only if there is a temporal relationship. What do you mean by temporal relationship? It means the change in one is affecting the change in the other variable. In what way the change is happening, that's a different discussion altogether, but some change is happening. So that is the purpose of scatterplots, to show how the variables are changing and how one variable is affecting the other variable. So in a given scenario, let's just say this is an example that is given to you, that a farm in upstate New York is evaluating whether or not to invest in an irrigation system. They have data over the last few years on average rainfall in inches during the growing season and pounds of apples produced. If the amount of rainfall is associated with the crop yield, they may choose to make the investment. This is your problem statement. You have two you have two variables at play over here. One is the average rainfall and pounds of apple produced. So you have average rainfall and apples produced. So one thing that we know for sure is that the amount of rainfall will determine the quality of the crops produced or the amount of crops that will be produced. If there will be more rainfall, more crops are going to get produced and vice versa. So clearly here you can see that your average rainfall in an agricultural space clearly has an impact on the number of apples produced. So here these two variables have a temporal relationship, and we can also surmise that average rainfall in an agricultural setting is key to determine the number of crops produced or the number of apples produced in this case. So we can say this is our explanatory variable and this is our response variable. Taking another example, the next example says the are SAT, math and verbal scores associated. To find out, a high school collects the data for math and verbal scores of their students. Now, if you look at scores in an exam for mathematics and verbal for an SAT test, now you know that your score in mathematics will not have an impact in your scores in verbal examination because the content of both the math exam and the verbal exam are different. And good performance in one does not guarantee good performance in the other. Now, one can say that if the student is really, really good, and if the student actually works very hard, he can actually score in both these scenarios, in both the exams. That's true. But does one have an impact on the other? Does a high math score always guarantee me a high verbal score and vice versa? That's not true. So here, the two variables do not have a temporal relationship. Now, mathematically, we can, if we would have had the data, we would have gotten to the same conclusion using the R function. Now, how do we do that? That's a topic that we'll be coming to very soon. So between two variables, there can exist a plethora of relationships. As we saw in this particular example, the relationship between hours of study and score is linear. And how can I say it's linear? Because you can see the distribution of points and a line, it almost seems like I can pass a line through the points. Therefore, I can surmise that the relationship between these two variables is a linear relationship. There can be other kinds of relationships. There can be curved relationships, there can be random relationships, and there can be cluster relationships. For our discussion in this particular series of sessions and covering this particular module on linear regression, the most fundamental and the most pertinent is going to be linear relationships. But to give you a brief context, if this is linear relationship, I can literally pass a line through this. A curved relationship is something like this. Somewhat like this. It's going to be a curved line that can represent the distribution of points. Similarly, for random, your points are going to be randomly arranged. And you cannot find a perfect polynomial that can accurately represent these points in space. Clusters are a unique clusters are actually a very unique scenario because clusters are basically when you have points scattered in such a way that some points are similar to one another and are different from the others in space. So this is one cluster of points and this is the other cluster of points. We will have a proper discussion on clustering and finding clusters in a later module. But for this module, we, we will go deep into linear relationships. Look for a linear relationship. For a linear relationship which looks something like this, which looks somewhat like this, as we saw in this particular relationship in R. Your relationship between the variables can be of two types. Either it can be positively correlated, the two variables x and y. Either they can be positively correlated or they can be negatively correlated. If they are positively correlated, it means that an increase in x will cause an increase in y. This is what positive correlation is. Or they can be negatively correlated. So, if two variables are negatively correlated, what it means is that an increase in one causes the decrease in other. So if I increase the explanatory variable or the magnitude of the explanatory variable, it causes a decrease in the magnitude of the response variable. This is what is referred to as negative correlation. So this right here is negative correlation. So we have understood positive correlation. We have understood negative correlation. Now, couple of points that I want to go over quickly. First is that the proximity of points, which means how close these points are to one another when I fit the line through these points. The proximity or closeness of these points determines the strength of the association. It means if they are, so this is referred to as the direction of correlation. If they are positively related or they are negatively related, they are relatively correlated. This tells you about the direction of the correlation. But how strong are these correlations? Let me take an example of two positively correlated scenarios. One is this. And the other is this. Again, this is an example of positive correlation. But if you see both of these cases, in this case, the points are much closely plotted again. They're very close to each other in space. Compared to here, Here the points are much farther from one another in space. Therefore, both of them are representing or showing positive correlation, but the strength of correlation is more here compared to here. It means that there is a high degree of change in y when x changes compared to here. This is the basic idea. Same goes for negative correlation, but what you need to remember is the direction of the correlation shows how the response variable changes when we change the explanatory variable, and the strength of correlation tells us to what degree the response variable changes with a certain amount of numeric increase in the explanatory variable. So these were the concepts of direction and strength in correlation. Now, all of these concepts are encapsulated in a mathematical parameter called correlation coefficient. Now, correlation coefficient gives you both the strength and the direction of the correlation between two numeric variables. It is a mathematical measure that shows both. Mathematically, this is given by 1 upon n minus 1 summation of xi minus x bar upon sx yi minus y bar upon sy. This is the mathematical representation of the correlation coefficient, but because we are programming in R, we have a function that calculates the correlation coefficient between two numeric variables. That function is called core function. So if I do core hours, score, this will give me my correlation coefficient. Now some properties of correlation coefficient. First, the correlation coefficient varies between +1 and -1. This is the range in which my correlation coefficient varies. Now, my correlation between y and x is same as that between x and y. So in your core function, if you give core of score, hours, it will yield you the same result. Now let us see how we interpret strength and direction from correlation coefficient. So correlation coefficient varies between -1 and 1. So rule number 1, when you are estimating a strength from correlation coefficient, the further away from 0 your value of correlation coefficient is, the stronger the relationship or the stronger the correlation. The closer to 0 your correlation coefficient is, the weaker the correlation. Let me repeat myself. The further away from 0 your correlation coefficient is, the stronger the correlation. And point number 2, a positive correlation coefficient, it means the direction of correlation is positive. And if the correlation coefficient is negative, it means that the direction of correlation is negative or descending. So positive or ascending, negative or descending. These are some of the basic concepts of scatter plots, and we also looked at the correlation coefficient that encapsulates all the necessary details that gets represented in a scatter plot. In our next session, we'll continue our discussion from here and we'll look at simple linear regression. Thank you so much for watching.